for our expert sessions. These were short webinars that took place every 2 weeks and last no more than 30 minutes, bringing you valuable insights from the industry experts. Today's session will be presented by Sonny Solanki, who's Senior Technical Manager at I-Gard. Sonny is an electrical engineer by McMaster University with 8 years of experience in protection systems and relays. Through his career, he has educated consultants and end users on the benefits of integrating electrical protection products into their designs to enhance personnel and equipment safety. He specialized in providing commercial and technical support for various projects and applications, including high-resistance grounded systems, low-resistance grounded systems, hybrid HRG systems, ground fault and arc flash protection systems, resistor-based solutions, and personal protection products. We're excited to have him here today, and we appreciate your participation. Let's get started.
Thank you, Andrea. So today's presentation is going to be IEEE 43 requirements for insulation resistance testing and the significance of polarization index and dielectric absorption, which are part of the insulation resistance testing process. So to start off, we know that motors over time consistently degrade with respect to their insulation. And in addition to that, frequent starts and temperature fluctuations can cause insulation to crack. And also idle periods allow moisture to build up when the motor is not in use, reducing insulation resistance. So unchecked degradation leads to unexpected motor failures and costly downtime for when you need that motor to be running for your processes. The IEEE identifies approximately 30% of motor failures are insulation related. Now, the reason why you would need insulation monitors is if your production conditions involve high humidity, dust, wetness, corrosive environment, or fumes of any kind. And given that a lot of industrial processes are involving these risks, we could see that insulation monitors are needed in these types of applications where the motors involved in these 5 different environments. So the benefits of having a permanently installed insulation monitoring unit is that we can detect insulation degradation before motors are energized, so that we know that when they are ready to be energized, they will come online so that they can do their process. We also minimize downtime with real-time monitoring to eliminate manual testing and reduce unplanned outages. And this will avoid expensive rewinding, failure to produce penalties, and overtime testing labor. In addition to that, with the permanently mounted unit, there's hands-off monitoring, which eliminates cabinet access to reduce arc flash risk. And continuous data helps maintenance teams make proactive decisions based on trending analysis. So the key features are continuous remote monitoring for safety and reliability. With the permanently installed relay, it provides hands-off insulation testing, covering applications from 600 volts to 13.8 kV. And it continuously monitors insulation levels and includes an integral self-test feature as well. We also have standard compliance testing with automatic alerts. So we perform insulation tests at NETA rated voltages between 250 volts DC to 5,000 volts DC, and trigger alarms if resistance drops below preset levels, ensuring proactive maintenance and preventing unsafe startups. So in addition to that, there's periodic insulation testing, and that is based on IEEE 43 requirements. This is used to detect early signs of insulation deterioration caused by moisture, contaminants, heat, or mechanical stress. It prevents unexpected failures, costly downtime, and safety hazards, and supports proactive maintenance planning instead of reactive repairs. So by having that continuous monitoring and periodic monitoring, we can actively know when the motor can have a planned maintenance rather than reacting to a motor not starting on site and then trying to figure out what's wrong with the motor at time of failure. So the importance of trending, as recommended by IEEE 43, is that individual readings may vary due to environmental factors such as moisture and temperature. And by doing multiple readings and providing trending analysis, it reveals patterns indicating insulation degradation over time. So as per IEEE 43, the recommendations are that for machines that are greater than 200 horsepower or 150 kilowatts, you perform a 10-minute test to calculate the polarization index and compare the 10-minute insulation resistance over the 1-minute insulation resistance to get a ratio. For machines that are below or equal to 200 horsepower, you can conduct a 1-minute test and compare the 60-second insulation resistance readout over the 30-second insulation resistance readout to get a ratio called the Dielectric Absorption Ratio, or DAR. The key standards that govern insulation resistance testing are IEEE 43, which is recommended practice for testing insulation resistance of electrical machines, IEEE 9095, which is recommended practice for insulation testing of AC electric machinery that is greater than 2300 volts, and also with high direct voltage. NFPA 70B is standard for electrical equipment maintenance, which also references IEEE 43, and NETA MTS-2019 requires testing under IEEE 43 guidelines for critical equipment. So in this graph here, we have four different current readouts that we're using to do the calculation. And the first one is the capacitive charging current. So it's a current that starts out high and drops after the insulation has been charged to full voltage. So basically, this is the capacitance from the phase to ground that is dissipating after about 0.7 seconds of the start of the test when voltage is induced. In addition to that, absorption current is this curve right here, which is also starting off initially high and dropping down after 10 seconds. And the onset of this is coming from our test input voltage that is being used to calculate the insulation resistance, and we're tracking this as a linear function going downward. Now, conductance or leakage current is a small, essentially steady current both through and over the insulation. And with good insulation, you could see that this graph eventually levels off once the steady value is reached, and it basically levels off to indicate good insulation. If this graph were to go up higher as the voltage is being applied, then there may be a poor insulation with respect to the conductance or leakage current that's being picked up, as it's not leveling off, which is an indication of good insulation. Now, for the Dielectric Absorption and Polarization Index, IEEE 43, NETA MTS-2019, and NFPA 70B mandate insulation resistance tests for calculating DAR and PI. So for DAR, the ratio of 60-second resistance to 30-second resistance is compared, and this is used to indicate short-term absorption of insulation. And for the polarization index, as I mentioned, it's the ratio of 10-minute resistance to the 1-minute resistance, and it highlights long-term dielectric behavior and moisture effects. So the table on the right indicates the insulation condition as dangerous, questionable, good, or excellent based on the DAR, which is the first column here, and the polarization index, which is the second column. So a dangerous ratio for the DAR test is anything below 1. And if that occurs, then we can indicate a dangerous insulation condition. Questionable insulation condition would be between 1.0 to 1.25. Good would be 1.4 to 1.6, and anything above 1.6 would be excellent. For the polarization index, anything less than 1 is considered dangerous. 1 to 2 is questionable. 2 to 4 is good, and anything above 4 is considered excellent. Now, with respect to full rated test voltage, NETA MTS-2019 recommends using a minimum DC test voltage based on the equipment's nominal voltage, and IM relays can produce a 5,000 volt DC test voltage, enabling installation monitoring and testing on systems up to 34 kV. So why test at the full rated voltage? We ensure installation can withstand the maximum operating voltage. It detects weaknesses that could cause failure under actual conditions. And the outcome is that we confirm installation strength and identify weak points and provide a safety margin for high voltage applications. So the table on the right, table 100.1, shows nominal rating of equipment voltages between 250 volts all the way up to 34,000 volts, as well as the minimum test voltage in DC that you should apply for each instance. So by having our relay be able to do 5,000 volts DC, we can cover the entire line from 250 to 34 kV. And then on the right column, we can see our recommended minimum insulation resistance in mega ohms that we should be achieving with respect to our tests. So this is our IRT relay, which is coming soon. It combines insulation monitoring and resistance testing in one device. We have periodic testing with dielectric absorption and polarization index, data storage for trending analysis that can be accessed via this USB port, and we have full compliance with IEEE 43, 95, and NETA MTS-2019 standards. So stay tuned for the IRT relay launch, your complete installation testing solution. If you have any questions, feel free to ask now, and I'll open up the questions pane. Polarization index and DIR are both destructive tests. They are not necessarily destructive tests since the equipment is rated for the test voltage that is being applied. So we do not feel that these are destructive tests. Where this relay can be installed in MCC or starter, it will see both cable and motor both. You can install at the motor end or on the load side of your MCC switch. That way, I know that you're also getting the cable and motor both, but cable inherently won't have that much impact on the insulation resistance test. And in addition to that, even if you install it at the motor end, you're also still going to be monitoring that cable leading up to where that disconnect switch or circuit breaker is open. How come it's only compliant to MTS 2019 and not the latest MTS standard? I'll have to check back on that, Johan, but good question. I'm going to check to see if the MTS standard has been updated and what it's indicating. So is it better to install at MCC load end? That could be an option for sure because you're already going to be considering those cables when the motor is disconnected, regardless of if you're close to the motor or further away. So at the MCC load end should suffice. Can a motor be restarted while the test is ongoing? The motor cannot be tested while the test is ongoing because there's an interlock that's going to stop the motor from energizing if voltage is still being applied during the test. Is this relay replaced yearly or 2 years PDMA test requirement? I'm not sure how often this test needs to be conducted, but I would suggest to follow the IEEE 43 guidelines to determine how many times you would have to do this test. I can probably get back to you on that one, Amit. Have you seen any situation where the insulation is good, but DAR is not for a motor? So because the DAR test is a 1-minute test, and if you just had recently shut down the motor, there could be a lot of moisture as the motor is winding down to a halt, and then you're performing that test immediately after that halted point, in which case you may not get as accurate of a reading. So it's recommended to apply your demoisturing options, which is most likely heating the motor to make that moisture evaporate before conducting the DAR test. Is it offline testing for these relays? Yeah, this relay's doing offline testing for the motors so that when you plan on energizing this motor, we know that if the insulation resistance is good, it should have no problem getting online. So the key point is if the insulation resistance is bad, then you would not want to start this motor knowing that the insulation resistance is going to cause the motor to trip out. I think that's all for the questions. I'll check back, Johan, on the MTS standard to see that we're reading on the accurate one, and I'll also check back with you, Amit, on the how many times that we have to conduct this test based on IEEE 43, and I'll get back to you on that. All right, thank you everyone this is our last session for expert sessions, and I hope you guys enjoyed all of the sessions before that, as well as this one. Feel free to download the handouts, which are located on the right, and Andrea will be sending out this presentation as well as the recording so that you guys have reference for it for future use. Thank you again, and look out for our next set of expert sessions, which should be coming in 2026. Take care.